Two different types of unique differentiation questions. I wanted to go through these because the format is a little different to what you're used to. What you're used to is where there's just a power already there. What we do to solve this type of question is write it out in power format. So the square root of x is essentially x to the power of a half. So we can write this as 4x to the power of a half. And then 1 over 2x. You have to be a little careful here. A lot of students make mistakes here. But this is essentially the same as 1 over 2 multiplied by 1 over x, or 1 over 2 multiplied by x to the minus 1. So a half x to the minus 1. That's how we're going to write this out as a power format. And then we have the plus 10. Now that it's in this format, we can apply what we know about differentiation. The fact that you multiply the power to the number before the term, the coefficient. A half times a 4 is 2x, and then you subtract 1 from the power. A half take away 1 is minus a half. Doing the same to the second term, minus 1 times a half is minus a half x, and then subtracting 1 from the power is minus 2. Now when you differentiate a constant, that's just 0, so we don't need to include that. Moving on to the next part of the question, we just repeat the same process. So minus a half times 2 is minus 1. I'm just going to write as minus x. You can write minus 1 here, but you don't need to the power of minus 3 over 2, because minus a half take away 1 is minus 3 over 2. Minus 2 times minus a half is positive 1. Again, I'm just going to write it as plus x to the power of, you take 1 away from the power again, so it's minus 3. Hopefully that makes sense. Let's move on to the next question. I'm going to do it in a different color. Once again, this is a format that we're not used to differentiating. What we do in this case is we separate it into 3 individual fractions. So we're going to write this first term 2x squared over the denominator, minus the second term over the denominator, and then the third term over the denominator. We can simplify this before we differentiate. So x squared divided by x is, well, the x cancels out and you're left with just 2x. X over x here cancels out and you're left with minus 5, and then 3 over x, I'm going to write that as 3x to the minus 1. Again, so it's in a format that we can easily differentiate. dy dx is of any term with x is just that term 2, because this is the same as 2x to the power of positive 1. 1 times 2 is 2. And then this becomes x to the power of 0, which is just 1. Minus 5 differentiates to 0, and then 3 times minus 1 is minus 3x, all to the power of minus 2. Or you can write this as 2 minus 3 over x squared if you want to. Either way is fine. I'm just writing it like this because it's going to help with the next question. It asks for the gradient when x is 3. So dy dx, what that actually tells you is the gradient of the curve. To find the gradient when x is specifically 3, we put that x equals 3 into dy dx, and we get that is 2 minus 3 over 3 squared. 3 squared is 9, so this is like 2 minus a third. So how I tend to do this is I make this term a fraction over 3 as well, so that we can easily subtract the fractions. But that's just too complicated, honestly. 5/3 is the answer, and yeah, that's all you need to know for this question. So hopefully you understood that, and if you have any questions, just let me know in the comments. Yeah, please like the video, subscribe. I'll post a new video every day, and in the description I've linked my tutoring email as well. So if you're interested, just send me an email and I'll try to respond as quick as possible. Thanks for watching.